Hello everyone, my name is Mihir Thakkar and I welcome you all to our Introduction to Computer Programming course at Code Heroku. We at Code Heroku are trying to make world-class computer science and engineering education accessible to millions of students out there, and especially in developing countries like India. In this course, we'll study perhaps one of the best languages to get started with computer programming, which is the C programming language. But this is not just a C programming tutorial series. In this course, you will understand what happens behind the scenes when your C program runs on a microprocessor. And you will also learn how to program this microprocessor using something called as an assembly language. But wait, you won't only stop there. We'll go one step even further and understand some details about digital logic circuits, and we will dive into the depths of this mysterious world of ones and zeros. And since we are not doing this course in 1990s, we won't be using such outdated tools to write our C programs. But instead, you will learn how to use modern tools such as Sublime Text to write your C programs. So perhaps one of the most common questions that students have when they are starting with computer programming is which programming language should they choose? I mean, there are so many options out there. You could learn Python, Java, C++, and so on. And I am sure that a lot of you will comment on this video and ask me if C is the right choice for you, or maybe you should learn Python or something else. And my answer to all of you will be, guys, seriously, it doesn't matter. I mean, it is more important that you don't waste a lot of time and start learning something rather than trying to find that perfect language. So I personally recommend using C language to all our students because with C, you can understand the details of what is happening behind the scenes in a computer's memory, which is sometimes difficult to teach and learn when you are using a modern scripting language, something such as Python. So just to go over a few logistics of this session, if you are watching this video live on its premiere, please do not use the live chat box to the right. If you just want to say hi, that is fine. But if you have any serious questions, please put them in the comment box below. Or if you want to answer any quiz questions, that's the right place. And the reason is simple. I want to make sure that I can answer each one of you individually, one by one. And this is very difficult to do on that live chat. Also, this chat will be gone once our video premiere is over. So people who might have benefited from your questions, they won't. So please be sure to comment in the box below. So here are some of the things that we want to achieve through this course. More than anything else, we want to spark a desire of learning more about computing in you. So in a sense, we want this course to serve as a launchpad for your awesome career in computer science or any other field that you want to work in. Next, we want to make you an excellent problem solver. So this doesn't mean that after completing this course, you'll be able to solve every computing challenge that is thrown at you. But instead, what we want to do is, even if you don't know a lot of things, you'll be able to work them out and find answers to those questions yourself because of the confidence that you will have gained after completing this course. And of course, we hope that you will learn some fundamental concepts in computing that will help you to take more advanced courses such as algorithms or data structures, right? So let me ask you, why should you even bother learning computing or computer programming in general? Again, guys, please be sure that you are asking and answering your questions in the comment box below. If you are watching this video live on its premiere, I'll reply to you immediately. So here's what I think about it, and you might have your own reasons, but let me tell you why am I so excited about computer programming in general. So first, it lets me build stuff, right? So I could think of some weird idea and go home at that night and write an app to create that idea into real world, which is quite fascinating if you think about it. Like I could create something with my hands. So there is this inherent joy of
creating and giving birth to something which didn't exist in this world before. That's a big part for me. So the next thing is that computing helps you solve some real world problems that are difficult to solve. So, for example, I recently heard of this young high school student who created an app that helps cancer researchers to diagnose breast cancer more effectively. So, which is quite a remarkable thing, right? It's giving you tools that enable you to solve some problems that we as humanity face. And I think it's one of the best things that you could do if your time or your efforts that you are putting into is helping someone else. So that's quite fascinating for me. So the next thing that I really like about computing that it's quite challenging and it's relatively new as well, right? I'm not saying that it's very difficult, but if you think about it, like other branches of engineering, mechanical engineering, civil engineering, or no, even chemical engineering, these have been there for quite a long time now, like more than hundreds of years at least, right? And if you think about computers, right? I mean, we didn't have them until last, couple of decades or so.
So let's dive in a bit. One of the first computers that was ever made, the difference engine, built by a Britisher called Charles Babbage. He started building it in early 1800s, and what it did was it could solve complex polynomials. And the Britishers gave him a lot of money to build this. So can you think why Britishers were so much interested in building a machine that could solve polynomials? Well, as you might know, the Britishers ruled the seas in those days. And with polynomials, you could approximate solutions to trigonometric functions. So essentially, someone could scribble some triangles on a map and tell you where they are or where they were. The project did not end so well. It was well over budget and well over time, just like most software projects today are. Actually, people say that halfway through the project, he got bored because he got an idea to build something called an analytical engine. Can you guys think of how the analytical engine might be different from the difference engine? Guys, again, if you are watching this live on Premiere, please be sure to answer your questions. Let's keep it interactive. As some of you might have suspected, the difference engine was built only to solve one specific problem of solving polynomials. But the analytical engine, on the other hand, was designed to be more of a general purpose machine. You could definitely program it to solve the polynomials, but it was not limited to just that. So instead of the smarts of the machine being in the hardware, which is so difficult and expensive to build, we would put the smarts in the software or the configuration of the hardware. And as you will see, this idea is the seed of all modern innovation in technology and computer science that we all enjoy. Charles did not end up building this, and it remained a plan for a long time. It was not obvious to the world for at least 100 years until von Neumann and his team built the ENIAC, one of the first electronic general purpose computers. What made it possible, what makes computers possible today, is something called transistors. A transistor, as far as we are concerned, is a switch. It has all sort of other useful properties, but for us, it is a digital switch. So here's how the symbol looks like. Controls the flow of current. The current wants to go from the source to the ground, but the controller controls it and says if you could go or not. So essentially, if you have 0 over here, the current can't flow. But if you turn this on, you give a 1 to it, the current flows from source to ground. And you could also have the inverted ones as well. So like this guy. So this guy works completely opposite of the first one. When you give a 0, it actually turns on and the current can flow through it. But if you give a 1, the current can't flow. Alright, so this brings us to our first quiz. We have two transistors over here, the inverted one and the normal one that we just saw. If you provide logic 1 as input over here, what will be the value of VO? Will it be 1 or 0? So I'll be waiting over here for a few seconds to answer any questions that we have received in the comment box below. Guys, again, if you are watching this live on Premiere, please be sure to answer your questions. Let's keep it interactive. If you are watching this video live on its premiere, please do not use the live chat box to the right. If you just want to say hi, that is fine. But if you have any serious questions, please put them in the comment box below. Or if you want to answer any quiz questions, that's the right place. And the reason is simple. I want to make sure that I can answer each one of you individually, one by one. So here's the answer. When we provide logic 1 over here, the about transistor turns off because remember it's an inverted one. It turns on only when you give 0 to it. And at the same time, this transistor turns on, so the positive voltage can't reach the output, but the ground or the 0 volts does reach over here. So let's see how to implement logic using transistors. What you see over here is something called as an AND gate. For an AND gate, the output is on only when both of its input are on. Let's see if that is true. Let's say you give 0 over here and 0 over here. So this transistor is off and this one is off as well. So the output at this point is 0, right? Let's say if you give 1 over here and 0 over here. So this 1 will cause this transistor to turn on and this is 0, so this is off. So the output still can't reach, the voltage still can't reach the output over here. So it is still 0. So let's say if you turn this one on instead. So this guy is on, but this one is still off. So the voltage still can't reach the output. This output will be 1 only when both of its input are 1. So this guy is on and the voltage can reach the output now. So this guy will be on now, 1. So my challenge to you is implement an OR function using transistors. So come up with a configuration just like we saw for the AND gate. Implement a similar configuration to have an output Q, which is function of A plus B. Again guys, please be sure that you are asking and answering your questions in the comment box below. If you are watching this video live on its premiere, I'll reply to you immediately. But even if you are watching a recorded session, I'll try to reply to you as soon as I can. So here's how you would implement it. Instead of placing both the transistors in series, you would place them in parallel. So what would happen is even if one of these transistors turns on, the current can flow from this VDD to the output. And thus you would get the logic 1 over here if any one of this inputs turns on. And as you see over here, the transistors have evolved over time as well. In olden days, we had vacuum tubes, which were bulky and operated at high voltages. Next, the bipolar junction transistor was invented, which we just saw in our exercises. And you must have seen it if in childhood you were the one like me who would open their remote control toys. And over time, people realized that you could stack millions of such transistors on a single silicon wafer to build what we call as integrated circuits. So we just saw how we could implement a simple logic using a few transistors. But remember, as I told you, now we have the ability to have millions of transistors on a chip. And now the challenge that we have is, how can we configure or program these millions of transistors to build complex applications? The answer to this question is by using something called a compiler. A compiler, which in fact is also a program, can convert a human readable string to series of ones and zeros a computer can understand. So as I told you, a compiler can take in human readable program as an input to it. The structure and the syntax of this input is what we call a programming language. And the programming language that we are going to learn in this course, and as most of you might have heard about it, is called the C language. So as you can see, here's how a C program looks like. I mean, you don't have to be a rocket scientist to tell that this program is going to print something on the screen. So let me now show you how we can convert this program into something that our computer can understand and execute using what we call as a compiler. And to convert C language into machine code, we'll use C compiler, right? So let me show you the compiler in action and prove you that indeed it can do what I'm saying. And guys, please check the description of this video where I have added the instructions how you can install the C compiler on your machine as well. So this is the file where I have written my C program. So let's just go ahead and open it. So let me just go ahead and open this in Sublime Text. So what we see over here is our first C program. And don't worry if you don't understand everything, because in the next class we'll go over each line in detail. But today I want to show you how a compiler converts this human readable program to something that our computer can understand. So next I'll open my command window and change the directory using the cd command to go to this folder where I have stored my file. So now we are in this directory. Next, the name of our C compiler is GCC. So I'm going to say GCC. Let's give the name of our file, which is hello.c, and a bunch of flags. And let's name the output file as hello. So I'm going to say -o hello. Let's press enter and run this command. So as you see over here, we have produced the output file, which is hello.exe in this folder. Let's go ahead and execute this exe file, and there it is. It says, hello, I'm your computer and I can do things that you can't. We have seen a bit of C programming and also how we could build logic using transistors. And I'm sure some of you might be wondering, well, I'm not sure how these things relate to each other. So let me show you how our course is going to be structured so that you can see the bigger picture before we dive into the details. At the lowest level, we are going to see how you could build digital logic. So you'll be learning things about transistors, gates, clocks, number systems, and conversions between them, and all that fun stuff. So essentially you will be dealing with whole lot of ones and zeros. And once you know how that stuff works, we'll see how you could put whole lot of transistors together to build a microprocessor. And we'll be using assembly language to program our microprocessor. Here we will also study about functional units that make up a computer, such as ALU, memory, IO, etc. And once you have this microprocessor, essentially we could write more complex programs in a higher level programming language. And in our case, we'll be using C for that. So this will make up the first module of the course. We'll be studying all of this in bits and chunks together so that we don't get bored with a single part. In the second module, once you have understood how a computer works, we'll see how we could build some cool stuff using it. So we'll be studying things like cryptography, computer networking, or building a database. Alright, so here's what we have seen in our class today. We went over a brief history of computers. We saw the journey from the ancient difference engine to a modern day computer. Next, we saw that how crucial transistors were to the development of the computers. And we saw how you could use them as digital switch to build logic. And once we had the ability to stack millions of transistors on a chip, we could build microprocessors. But the question then arises is, how do we configure these millions of transistors? And the answer was using something called as compilers. And at last, we compiled and executed our first C program. So congratulations to all the guys and girls who were able to execute their first C program. Alright guys, so that brings us to the final part of today's video, which is the homework assignment. As I told you guys, this course is about learning by yourself as well. So my first question is, what is the difference between a programming language and a scripting language? And is C a programming or a scripting language? My next question to you is, what is an assembly language and why is it required? And this is our third and the final question. So while compiling our first C program, we saw that we used a flag called -vol. What does it do? And also, can you try compiling your C program without specifying the name of output file? Does it even work? Or if it works, what's the output? We also have a class WhatsApp group. So if you would like to be a part of that WhatsApp group, please go ahead and message me on the number given in the description and I'll add you to that WhatsApp group. So we generally do all our sessions live on a Zoom meeting, but this is the first time we are trying out this format. So if you have any suggestions or any feedback on about this format, please let me know in the comments below. We'll let you know on the WhatsApp group when is the next class. Most probably it will be next Sunday. So till then, goodbye.